So in this problem, we need to verify that cosine of 2 theta plus sine squared phi equals to 0 whenever tangent squared theta equals 2 times tangent squared phi plus 1. Let us begin. So here, we will begin by first finding out the value of cosine 2 theta, and we will find out cosine 2 theta in terms of the tangent function, which is given by 1 minus tangent squared theta divided by 1 plus tangent squared theta. Now, luckily for us, tangent squared theta, that's value is given to us. So let's replace tangent squared theta with 1 plus 2 times tangent squared phi. Divided by, we have 1 plus tangent squared theta. So that will be 1 plus 2 times tangent squared phi. Now, in the numerator, we'll be left with negative 2 times tangent squared phi. And in the denominator, we have 2 multiplied to 1 plus tangent squared phi. So this 2 and 2 gets factored out. Now we have negative tangent squared phi divided by, now 1 plus tangent squared phi, that's an identity, which is secant squared phi. Well, we now have cosine of 2 theta, that's equals to negative of tangent squared phi divided by secant squared phi. This will be equals to, now tangent squared phi, so we can write in terms of its sine and cosine is sine squared phi over cosine squared phi. And secant squared phi, it's in the denominator. If we take it to the numerator, that will simply become cosine squared phi, because we know that the cosine function is the reciprocal of the secant function. Now we can factor out cosine squared phi, leaving us with negative sine squared phi. And if we write everything, we get cosine of 2 theta added to sine squared phi, so this will be equals to 0. Hence, we have successfully showed that cosine of 2 theta added to sine of 2 phi will be equals to 0 whenever we have the condition that tangent squared theta is given by 1 plus 2 times tangent squared phi.